Hello everybody, I'm your host Hal Curtis and I'd like to welcome you to The Space Industry by satsearch, where we share stories about the companies taking us into orbit. In this podcast, we delve into the opinions and expertise of the people behind the commercial space organizations of today who could become the household names of tomorrow. Before we get started with the episode, remember you can find out more information about the suppliers, products and innovations that are mentioned in this discussion on the global marketplace for space at satsearch.com. Hello and welcome to the episode. Today I'm joined by Riccardo Carlini from satsearch member company NPC Spacemind, and we're going to be discussing flexibility and rapid delivery in the new space sector. Spacemind is based in Italy and is actually the aerospace division of NPC, or New Production Concept, a well-established manufacturer of automated machines for all sorts of different industry sectors, and we'll touch on that a little bit later. NPC Spacemind offers various products and services for CubeSats and other form factor satellites to help operators build better missions. So, Riccardo, thank you very much for being here with us today. Is there anything you'd like to add to that introduction before we kick off our discussion?
Hi, Howell. It's my pleasure to be here, and that's pretty much it.
Oh, great, thank you. Nice and simple. Okay, so first up, what attracted a company like NPC, which, as I mentioned, has been operating outside the space sector in the field of industrial automation, to enter the space industry?
So, given the initial success of NPC in industries such as industrial automation and packaging, the company was looking for diversification, investing in an emerging market. The goal has been reached in 2014 after a meeting with a team of university students that were carrying on a startup idea based on innovative technologies regarding nanosatellites. The two businesses' ideas merged together, bringing the creation of an internal division of NPC dedicated to space field, Spacemind.
Right, interesting. That's an interesting history there. Was there anything that surprised you at the company about the way that the space sector works compared to these other industries?
So, whereas other more traditional common industries depend on proven solutions based on factors such as simplification and efficiency, the new space is a rapid growing, highly innovative, and technology centered industry. The most fascinating thing about this sector is how dynamic it is, where almost no equilibrium exists among the players. An increasing number of private companies join the space market, and they're all fiercely focused on innovation, providing state-of-the-art technology, continuously overturning the hierarchy.
Fascinating. Yeah, I think we've seen that in a lot of different areas with a lot of different businesses as well. So in your view, over the last, I don't know, maybe say 3 to 5 years, how do you think the landscape of CubeSat missions of different sizes has changed, and where does it stand today? By that I mean, how long does it take to produce CubeSats? How much of new development needs to take place that is mission specific as opposed to more general? That's those sort of areas.
All right, so CubeSats were initially designed for education and research activities, or in-orbit, low-cost technology demonstration devices, which could be developed and launched in a couple of years. In recent times, CubeSats started to transition from the educational purpose to valuable private company missions as more and more advanced small satellite projects have been conducted, proving their high potential in terms of technological return and commercial value. Nowadays, it is possible to produce a complete CubeSat in a couple of months, depending on the payload complexity and application. The market imposes shorter and shorter production times. For instance, at Spacemind, we received an order for a 12U CubeSat, which was designed, developed, and delivered in 2 months.
Right, that is rapid. So shorter production times presumably have required you, especially when you've got a deadline of 2 months, to use things like commercial off-the-shelf products, COTS components, and they're a big feature that we've seen in a lot of CubeSat systems. How do you at NPC Spacemind, how do you make sure that COTS components can survive the space environment, and provide a reliable lifetime operation over the mission's course?
Yeah, New Space indeed allows the use of COTS components, which tailors down hardware development time. However, small satellites must go through a qualification process, which is still based on the ESA standards, ECSS, and NASA gives to reduce the risk of failure during the space mission. Due to their general lower complexity with respect to medium and large satellites, the testing process is tailored to reflect this. Qualification tests are performed on engineering models at system level instead of component level, and usually these are limited to thermal, cycling, and vacuum, shock, random, and sinusoidal vibration. All this is done to simulate the harsh space environment to guarantee that the COTS will survive in space. Nevertheless, the ultimate proof is obtained by actually launching the satellite in orbit.
Yeah, absolutely. With all the standards in mind and the testing qualification in mind, how much of a CubeSat, a typical CubeSat, as you mentioned, it varies depending on the application and the complexity of the payload. But how much do you think of a typical CubeSat can be created using pure COTS components or subsystems? And are there any particular bottlenecks in this process today?
Small satellites missions can be entirely performed by just using commercially off-the-shelf components, which usually truly reduce costs, power, and manufacturing time compared to rather hard ones. Not every COTS is though suitable for space application. In fact, those components might be able to pass all the required tests we discussed before and still failing to withstand the multiple radiation effects present in orbit. Despite the difficulty of sorting suitable COTS from the unsuitable ones, given the unpredictability of those effects, one strategy can be performing TID tests, total ionizing dose tests, up to 30 kRads, and picking those components which are still functional, as well as introducing components redundancy where possible.
Obviously, the use of COTS components, as you mentioned, enables these economies of scale, but it also enables CubeSat integrators and operators to use components and subsystems from different suppliers. But are there any challenges in using COTS subsystems that are supplied by different suppliers and ensuring the integration is effective?
Generally speaking, commercial aerospace modules such as onboard computers, electrical power systems, and so on from different suppliers can be integrated and connected together with almost no problems, since they're all designed to comply the PC 104 standard. Challenges, though, rise up when it comes to integrate those COTS payloads that are not designed to be implemented in CubeSats. Space inside those platforms is quite limited. For example, it happens that Spacemind has to accommodate optical imaging payloads in 6U or 12U satellites, which have never flown. In those cases, we need to make sure that the payload electronic can communicate with the rest of the satellite subsystems and that it is properly attached to the main structure. This process is often done by designing an appropriate electrical and mechanical interface, and it consists of one of the strengths of Spacemind. Common example of this procedure relate to the integration of solar panels and deployable mechanisms.
Obviously, I think a lot of what this is leading to for relevant contracts is mass production, and perhaps NPC's heritage as a business in different industrial sectors has given you some insights and some expertise there. But in the space sector specifically, have you found, or do you think there are any specific pitfalls that should be considered when looking to expand to a mass production, both at a subsystem level and I guess at the complete satellite level?
The biggest problem when it comes to series production of whatever space-related product is certainly the quality control. As the production numbers increase, the single subsystem must be thoroughly analyzed, as the slightest flaw can possibly result in a catastrophic failure of the entire satellites once in orbit. Among the strengths of Spacemind, we fall back on lean production, world-class manufacturing, and total quality management methods, largely utilized in the automation field by NPC, to ensure the highest quality of our products.
So yeah, quality control on the technical side, absolutely vital. But mass production, of course, is a commercial challenge as well. So, and we've seen, how companies such as OneWeb and SpaceX are approaching this at the real far end of the market. So, I wonder whether you thought that mass production of CubeSats will increasingly need to rely on mainly vertical integration of all the subsystems, or by building a vendor base specialized for every subsystem.
That's a good question. Surely companies will try to offer an end product in terms of CubeSat to their customers, integrating all the required proprietary subsystems, so to lower costs and increase the revenue margin per sale. However, certain subsystems and payloads require a very specific know-how, whose acquisition can be really expensive and not justifiable to be produced in-house. Spacemind is actively working from the subsystem and payload integration point of view, so that the customer only interfaces with us to configure the satellite based on their requirements.
You mentioned earlier that the ultimate test for any space application is how it performs in orbit. Mission reliability in when mass production is used is obviously another challenge as well. I mean, how do you go about ensuring overall reliability of mission life when using mass production methods, or does it, conversely, does it actually get easier to ensure greater mission life with mass production?
Usually, small satellite subsystems are designed to satisfy a specific set of operations. The mass production of those has two positive effects. On the one hand, the repetitive usage of the same product provides a frequent feedback and consequent data collection on it regarding its reliability of mission life. On the other hand, using the same product for missions for which it is not designed for can initially endanger or lower the mission life. Although this might be perceived as a downside of mass production, it actually influences positively the development of new products, going to improve and enlarge the operating range of such devices, thanks to the exposure to unknown scenarios.
There's the challenge there of how much is repeated and how much do we try and push the envelope. That's interesting take on it. Now, obviously, we've mentioned that the NPC, as opposed to NPC Spacemind, has traditionally operated in various other industries. You mentioned industrial automation, packaging, etc.
Yeah.
Have there been any opportunities to take advantage of these experiences in the space sector?
NPC ability to operate in industries where efficiency and reliability are the key points of its success confers to Spacemind several advantages. First of all, the adoption of NPC's production capacity and automation strategies guarantee us short lead times, a critical aspect for the future of nanosatellites. Second, we rely on a strong supply chain management for Spacemind's resources, so to offer the most cost-effective solutions. Third, we keep the strict quality control checks that characterize the industrial automation sector for our space-related products, providing trustworthy hardware to the customer. Finally, Spacemind takes advantage of NPC's industrialization capabilities, streamlining the transition from prototypes to series production.
That's a range of different challenges there, and it seems like you're trying to use the heritage of the company in the best way possible. So, best of luck with everything. Finally, I guess you have a bit of a unique viewpoint on the sector, coming from outside but being deeply embedded in the space industry for a number of years. So, I wondered if I could just ask how you see the new space market changing or developing in the next 3 to 5 sort of years. Are there anything? Is there any areas that you're particularly excited about, for example?
The new space market is moving at an insane pace, especially the small satellites one. Those indeed have the potential to make satellite-based science more accessible than ever before. Whereas years ago, satellites exclusively belonged to government agencies and wealthy corporations, now we are shifting towards the concept of personal satellites, where almost everyone would be able to send things in space. In 2018, 253 satellites were launched worldwide, and this figure is expected to increase substantially in 2023, with more than 600 launches. Large constellations, inter-satellite communication technologies, AI applied to Earth observation, such as automatic anticipation of future problems based on telemetry. These are only few of the future application of small satellites. And personally, I can't wait to see an increased use of CubeSats for deep space exploration, going beyond their orbit.
Yeah, I think that's something a lot of people in the industry are excited about. And we see the big exploration missions. We see Perseverance landing on Mars, and we think, well, what role could our business play? What role could my team play? And I think, yeah, that's something that teams should think about moving forward. So, great. Well, I think that's a great place to end our discussion. Thank you very much for sharing, your views on the flexibility and agility and mass production in the new space industry. It's been really interesting to learn about how a company with expertise outside the space sector can bring that to the market across both sort of products and services. So yeah, thank you very much for your time today, Riccardo.
Thank you so much for having me.
Great, and for anyone listening, you can find out more about NPC Spacemind's full portfolio of products and services, as well as make requests for datasheets, quotes, introductions and more at the global marketplace for space at satsearch.com. Thank you for listening to this episode of The Space Industry by SatSearch. I hope you enjoyed today's story about one of the companies taking us into orbit. We'll be back soon with more in-depth, behind-the-scenes insights from private space businesses. In the meantime, you can go to satsearch.com for more information on the space industry today, or find us on social media if you have any questions or comments. To stay up to date, please subscribe to our weekly newsletter, and you can also get each podcast on demand on iTunes, Spotify, the Google Play Store, or whichever podcast service you typically use.